Hello, everyone. Thank you for joining. I have a very special guest today, Allen Webster. Um, for those who don't know, Allen wrote the text editor for Coder, which is a text editor for programmers, and you can download it. It's open source now, right?
hmm
And you can download it at forcoder.net, I think, right?
yes, if you go to forcoder.net, you'll find a place where you can download the binaries, and where you can. Let's see. If you go to the Handmade Network Discord, I don't know any better way to get there. There's a forcoder Discord, and it's in the hand. It's linked from the Handmade Network Discord. I should probably put a public link to that somewhere. But the reason I'm mentioning it is there's a bunch of folks who still maintain an open source fork of forcoder now, which I'm not involved with anymore. But yeah, there's more up to date stuff than what's on the forcoder.net website right now.
Awesome. And just recently, you recently announced your own software lab, and
Yeah,
Mr. at MrForth.com. And
yep,
Alan's been working on some really cool projects about from deep diving into dynamic linking and having you've created your own library, and you've shared that, and if you would like to support the lab, Alan, I'll let you talk about it. You're
yeah,
probably better at
yeah.
talking about that than I am.
That's great. Well, thanks. Yeah, you can support the lab at mrforth.com/membership, and the support goes to doing their research projects. If you check out the blog, the most recent blog post has a list of my research projects and describes various perks you get for being a supporter. But the main idea is I want to be able to work on research projects that have a lot to do with the interests of people who are programming. There's a lot of indie programmers like Dan. You're working on this operating system and other Zig projects in your spare time. And there's other folks, a lot of people at the Handmade Network who do small teams or individual projects. And a lot of the problems that I have found that I ran into, I worked on development tools like Forcoder, I worked on the RAD debugger, and I found that a lot more often than not, it was really hard to deliver improvements on the development process, not because there's no theoretical way to do it, but because there's no practical way to do it. So I call what I do practical research. It's not about advancing the theory of what's possible, but advancing the practice of what's possible. Trying to figure out like what are the practical roadblocks stopping us from having, better experiences developing software, getting it right, getting it done efficiently, things like that. And I try to make it so that it applies to regular programmers, independent programmers, the stuff that we actually do day to day. Which means I want to be funded by the people I'm applying it to, and that's why I have a membership program so that I can get individuals to all pitch in. And if you think I'm doing cool projects, I'd appreciate taking a look at that.
Definitely. So, thank you. Yeah. So, really happy to have you on. And so, I think today we're gonna Alan has some experience with immediate mode GUIs. I have very little, even though I did write a very rudimentary one for BoksOS, largely inspired actually by Ryan's blog posts. And So there's a couple things I'd like to go over today and see if I can how I can improve basically anything. And I just like have I guess like there is more things off the top of my head like vectors versus scalars, floating points versus integer, um, and there's also I guess like a state, I guess like a global state. So
Mm-hmm.
um, I guess let's see here. So is there anything in this list? So vectors versus scalars is like really an integer float point versus integer is like the same thing. It's like for like the just like the coordinate system and everything
Yeah.
using those things, and the API in general. Um,
Mm-hmm.
and uh, um, but is there anything here? Default strictness that's for I'd imagine you're familiar with like the the strictness like field and like how to like expand or
We're
like
talking about like from Ryan's approach to
yeah,
the map
exactly,
layout. Yeah.
yeah,
Yeah.
yeah. Stacked when how to implement proper window stacking. Essentially, this is
Right.
like the same
Right.
thing here. So is there any topic here that you'd like to get into or look at the code
Yeah.
first?
I'm gonna flag a few things that I do and don't have maybe some insights on.
Okay, cool.
So the there's also some spots where I have questions. So at the level of what the operating system has to do, I'm a little curious, and I know we talked about this. When
Yeah.
you're writing an IM GUI library that you just use to create your own little tools or to create a product, you are thinking of it as I have a window and I'm going to fill
Yes.
that up with graphics and interactive elements will respond to inputs in a logical way that, the graphics on the screen are going to correspond to locations where interactions will be understood. So a button pixel lines up with the pixel where the mouse has to go, stuff like that, like
Yeah,
obvious stuff,
exactly.
right? And that's all you're really thinking about there. When a operating system is thinking about graphics, it's not thinking I have a window, right? It's
Yes.
thinking I have a screen and there are multiple windows coming from separate users that need to overlap or get moved around separately. I need to be able to resize some of them and stuff. And I'm not as familiar. Right? You're the operating system guy. I know kind of in theory that that has to happen, but I don't know a lot about what that process looks like. And I think that that's the piece where I'm a little unsure where. Um, I guess I'm curious. Like, are you using IM an immediate mode UI inside the kernel? Is it that the API facing the user is immediate mode? Like help me understand a little bit about what an immediate mode user interface operating system level version really means in this program or in your operating system.
Yeah. So there is a couple of things. So
I'm gonna
in
take
general,
notes while you're talking.
okay, sure, absolutely. Um,
Good.
so in general, the way I have things set up right now is, and what I have in my mind, honestly, is immediate mode and user mode. Not necessarily that the kernel doesn't really have, in my mind, the kernel won't really have a concept of of an immediate mode GUI. Um, I don't think it should actually I'm not going to even. I don't think. Maybe I would try
Yeah.
to experiment with that, but that wasn't really even. I wasn't even thinking about experimenting with that. So in general, I'm thinking about user mode, immediate mode GUI. But um, I don't have BoksOS to a point where I'm really running too much things in. Actually, right now, the BoksOS I demoed in at Handmade Seattle in 2021. That was actually a different code base, and that actually did have user mode. And I am actually very close to getting user mode working um, on here, but uh, in general, the kernel, the IM GUI is running in kernel space, at least right now. But the plan is so here's so I guess the plan eventually is I was thinking there would be like two different things. I would experiment with this. Um, so one way, which is actually the way I'm probably going to start with, and I am starting with that, is that each application um, is just going to request like some portion of the screen. Um, and um, or rather, I'm trying to think of how to succinctly phrase this. Um, Essentially, what I am going to do, at least initially, is going to have the operating system provide the application with a frame buffer, and the frame buffer is actually going to be the size of the screen. Um, but um, when the program is ready to tell the operating system to draw the window or whatever, it's only going to give a subset of that frame buffer. So in that sense, the immediate mode state and everything can be completely contained into the in the application. The
I
operating, yeah,
understand.
yeah. So the operating system doesn't
Okay,
have to know about that.
got it. So we're not. I was trying to figure that out for a while because you talked about the immediate mode user interface in BoksOS a couple of times,
Yeah.
and I was trying to figure out if we were talking about like because if you I'm going to draw a comparison to operating system APIs that I know, which are like on Windows, you can go and like there's create window, right? And
Yes.
create window is like this big calling create window is an adventure of its own where
Yes.
like several calls
That's
you
what
got
I've
to
seen.
make
Yeah.
before and after to actually do anything with it, and then you still don't actually have a graphics. Attaching graphics to the windows another interesting adventure.
Yeah.
The the point is you have this API that specifically says let's create a window, and uh, one of the things you do with the window once you have it is you figure out how you're going to fill its back buffer, and then presumably the compositor is doing something from there. Either they're setting the back buffer up to be the actual data, or like they have to read memory out of your user space into the kernel to do the compositing. Or I don't know exactly what their algorithm looks like, but
Yeah.
what I've been curious about when you've talked about this is if compositing, because you talked about putting windows stacking. That was one of the things on your list, right? You had
Yeah. It
window
was.
stacking, and I was a little curious how windows are we talking about window stacking within a application. Like if I'm writing my own application and I have a window, like I have a real operating system window, and then I'm using my UI, I can sometimes have like floating elements within my window being a convenient thing. Like for instance, if I have a tooltip, I hover over something, and the tooltip is just going to eclipse whatever is behind it. So it's a unique panel, a
Yes.
separate window from all the other UI. It layouts on its own. It goes over them, but that's not the same thing as user controlled click and drag like framed windows, which I would usually think of as like that's the thing the operating system is
Would handle.
providing on its own. So I don't know. What do you think about that? Are you trying to build like a user mode API that has windows inside of the OS windows, or are when you talk about window stacking, are you talking about window stacking the kernel has to do?
Yeah. That is actually a good question. So actually, now that you're talking about it, I'm thinking that the window stacking is probably you're probably right where like the window stacking is probably not really doesn't have much to do with the IM GUI. However, uh, oh hey Asaf. No, I actually I tweeted about it. Maybe I should have posted in the Handmade Discord. I tweeted
Yeah,
about it last week. Sorry.
I was
Uh,
thinking about announcing it, but I just had the last couple days kept slipping my mind. But
yeah, no, it's totally fine.
yeah,
Um, so so I guess it would be nice just from a knowledge perspective to actually know how you would handle window stacking in a user mode provided IM GUI,
yeah.
and then maybe I can extend that to a kernel. And honestly,
Oh,
I'm oh, sorry.
Asif says that my volume is really
Oh,
low.
really?
I
Okay.
don't know
Uh
if we can fix that.
oh. Um. Uh. Talk now.
Hello,
Is that better?
Asaf, are you still there to check it out? Thanks for dropping in and giving us feedback. We
Yeah,
forgot
we
to
should have
ask.
asked.
We just got right into it. There's
Yeah.
a lot of interesting stuff to talk about.
Yeah.
Okay, cool.
Cool. Awesome. Yeah. This is the first time also I've hosted somebody, so yeah. Apologies for that.
Yeah.
So Um, I'm trying to think. So all right. One. So I was thinking that the kernel that um, my actually intention for BoksOS is to be more of a microkernel design, where everything
Can
else.
you tell me? Yeah.
Yeah,
What
yeah.
would that be?
What the hell is microkernel, right? So, like the kernel, the quote unquote kernel is the only thing that runs in ring zero is like the CPU driver, essentially.
Okay.
So like scheduling, memory allocation, um, and I think that's it's just basically and facilitating IPC. Um, so that's really my intended design eventually. Um,
Would it be fair to say that the idea is just to make the kernel ring zero code as absolutely small as you can get away with?
yes,
Is that the goal?
absolutely. Yeah,
Yeah. Yeah.
that's exactly what it is. Um, and then I have like I don't want to get too deep into it, but I have like ideas of like I don't know if these are good ideas or not, but like just experimenting with like IPC like like kind of like Go channels, but instead of like having to go through the kernel to to like pass data or anything like that, it would just go straight to the other user mode process. So things like that.
Hmm.
That's kind of what I'm aiming towards. But I actually want to write something up before I actually, because people may say that's a terrible idea for some, performance or
Yeah.
whatever. But anyway, um, another idea. So one idea is to have that like the kernel doesn't really know anything about, or the video driver doesn't really know anything about what a window is, and then you just like give it parts of the screen essentially. And then maybe there could be kind of like an immediate mode driver, like where it the driver understands like the blocks of the immediate mode GUI, or widgets or
Okay.
whatever.
So I think it'll be helpful. I'm gonna tell you what I think about doing floating windows in an immediate mode GUI
Yeah.
just in general, like
Yes.
in the user space stuff that I do. And I think I'm going to tell you what the punchline is up front, and then I'll take you through the
Okay.
steps
Cool.
a little bit at a time and get back to it again the slow way. But I'm not sure that I think about. I'm not sure that IM GUI. I guess the very blunt way to put it is I'm not sure that IM GUI is compatible with overlapping windows
Mm.
in the way that you would expect IM GUI to work for everything else.
Ah.
And so here's what it comes don to is when you are first of all, we take a step back and think about why you use an IM GUI API structure. It's
Yes.
that it allows you to uh, directly connect up the state of an application to the code paths that specify what the UI looks like from that state. So basically, you can think of it as displaying in a very uh, abstract way of thinking about it. You have some application with some state, and that state is like the state of all of its memory or whatever. And you need some kind of mapping from that state to a frame buffer that shows the UI in terms of the graphics,
Mm.
as well as some kind of data structure that can be used to handle inputs and update the state, right? So you have this there's this interactive element. It's not just an output image. We're not just talking about generating graphics. We're talking about generating a pair of things that go together: graphics plus this description of interactive potential, which
Yeah.
is things like clickable buttons, input text boxes, and those things. What IM GUI does that's very special is that since you need to output both of those to make a UI, IM GUI says, hey, since one of those things is something where we need to use code, right? The graphics is just graphics. If that's all we needed, it would be easy. But the other thing we need is we need to be able to write some actual state modification stuff. Like we need to go back into the UI reaches back into the state and modifies things. And so that's the job code does. Like code is the thing. Code is the tool you want to modify the state of your program. Like that's what code does is it creates a blank program and turns it into something, and then turns that something into something else over and over again, right?
Yes.
And so we don't want, if you go retained mode, you get into situations where like, well, you don't write code to describe the update of state. You create object models. You create like this button has a handler, and we've
Yeah.
attached, and that handler turns out to be code too, by the way, but like it's like somewhere else, and like you set it up so that when this thing gets clicked, the object of the button knows what to do. And in
Yes.
immediate mode, what you're saying is that mapping is going to be kind of implicit. Instead of giving you a data structure that describes the interactive potential, the interactive potential is going to be a combination of the code that you wrote and the state that exists together, and it's going to arise implicitly as the immediate mode code runs.
Yes.
There's not going to be a data structure actually output by this. So that works. That's super abstract. So I'm going to
Yeah.
make it one step more concrete. When you have overlapping windows that a user can drag, right? If I can take your window and move it 1 pixel this way or 1 pixel that way, or if I can rescale it, then the position and scale of each window is a part of the state, right? It's actually that those are
Yes.
changes to state that have to feed back into the state,
That's
and
the
then
program.
that state then maps to where the windows go over and over again, right? It is not like I am deriving the state of the position of windows from implicit stuff. Somewhere there must explicitly be a position for this window
Yes.
and a width and a height for this window.
Right.
That's just directly in the state. And so where the immediate mode API stops helping you is whenever it comes to managing the actual state of things, right? The
Mm.
actual state of things lives
Okay.
outside of the immediate mode UI. The actual state of things is your code. And so if there are windows, like if I'm writing a program where you can create windows inside the main window and overlap them and stuff,
Mm.
then I consider the position and size of windows to be state that the program contains that is then going into that implicit mapping. So I might have like my definition of a window will not be I am GUI underscore window. It'll be my app underscore window. It'll have a position and size. And then when I'm going to do a render of the frame, I'm going to loop over all of my program side window data structures
Mm.
and create boxes for each one. So the immediate mode system gives me a way to say, create an outlined box here, put this frame on it, right? That's what the immediate mode UI gives me, is the ability to say, here's what goes at this location. Here's, the layout and the ordering of things and layers and stuff. But the state for where it is and where it is it includes its layering, but also X, Y, width, and height. That is actually state. So it goes on the program side, not on the immediate mode
When
side.
the
Which,
graphic side, yeah.
yeah, yeah, yeah. Which means, okay, taking this one step closer again to immediate mode UI for an operating system's Windows, I think the same thing applies there. I think that um, having immediate mode UI system is great, but it does not. It is not the tool for solving this. What you need is a Windows system. Like
Yes.
a Windows system is
Correct.
just a separate thing. A Windows system is a set of states for your separate windows, and then a a piece of code will use the immediate mode library. Like you'll have a base level immediate mode system, and you'll be able to take your state of your windows and build the window presentation, or the presentation of the screen, out of the combination of the state of all the windows with the immediate mode library. But they're
Yes.
separate. They're separate layers, kind of. Does that make sense? At least that's the
Yes.
way I tend to build it. So that's what I'm giving you.
Like, yeah, like the typical, like the state of all of the windows in an IM GUI system is all handled by the program itself.
Yeah.
Like there's no, you're not going to have like a separate manager system for any of that, which is,
Right.
yes, which makes sense.
Yeah. And I'll give you like a more concrete example of why that's the way I like to do it too. So when we think of operating system windows, we think of them kind of like the ones that contain our applications. Actually, like if you're on Windows and you do Windows graphics programming, you know that like buttons are windows. Like every rectangle is they have like a rectangle tree basically, but instead of calling them boxes or cells, they are each
Mm.
one is called a window.
Okay.
So window means something a little funnier than you might think, even from the perspective of the Windows operating system.
Oh, okay.
But but when we think of window, we are thinking of the thing with the frame that you can resize and make it full screen and stuff like that. And if I was creating an application, I would not. I would also say that that's not the only thing that really is interesting to use as a window, right? There might be a list of those, but like I was saying earlier, a tooltip is a good example of the exact same basic problem, which is that it's a rectangle that is laid out independently from the layers behind it,
Mm.
and it is not something that you can click and drag or resize because it implicitly shows up based on the state of the application and the location of the mouse. And so what's actually happening is, the UI system is detecting that you're hovering something, and then that is implicitly generating a box that hovers over everything else, and that has it might have, sometimes you might want continuity, the previous frame and the next frame. As you're moving your mouse around, maybe you want your tooltip to fade away if you move it off,
Mm.
or
Yes.
the tooltip might actually, right click menu is another good example of this. A tooltip usually follows the mouse, whereas a right click menu, once you've created it, you want it to kind of stay there and give you a
Yes.
stable interactive window that kind of hovers, but it wouldn't be a window you could relocate and resize like a framed window.
Yes.
So the point of all that is to say, in addition to the data structure that's just like, here are my explicit windows, you also want window in an immediate mode context. You want things that are like, oh, I'm in tooltip state. And the tooltip state is just a Boolean
Mm.
and a string. It's like, true or false, are we in tooltip state? And if we are, what's this tooltip string? And you can think of that as like, that's the whole state. But so then you are implicitly going to generate the window that contains the tooltip, or the floating box that contains that tooltip. Um,
That makes sense.
and if instead the immediate mode library had said, here's how you create floating boxes, you instantiate them and you update their states. Now as soon as you start a tooltip, you have to go, oh, a tooltip has started, we were previously not in tooltip state, so
Oh, yeah.
instantiate visibility for, right now you've got the whole retain mode thing again.
Yes, exactly. So that makes sense, and that's why like those like widgets or blocks or whatever, like those structs tend to be pretty large because like you want to have all those options available,
Yeah.
um, and you can pack things into flags and stuff like that. But um, and that makes sense, and that's why I'm like thinking like I think like I always knew that like immediate mode GUI doesn't make sense from like as a system call. Like that doesn't make
Yeah.
any sense. Like
Yeah.
I always knew that. Um, but I also had kind of an idea um, where maybe there could be some sort of program that does take in these widgets or blocks, and then it uses that to draw the entire screen of across all programs. I don't know if that's really a good idea or not. I mean, I don't know if that's really been done. I really don't know. Um,
Interesting.
yeah.
So while I don't know how that'll work for a kernel, that is kind of what a immediate mode GUI system kind of ends up looking like. So like usually what you have is, you break it down into like phases like this. You have, usually there's some preamble, like you prep, you consume input and prep for it. So like things like Alt F4,
Yeah.
your hotkeys are just getting tested and stuff, um, things like that. And then you have a section which is that where that immediate mode UI API gets used heavily, where you're doing that mapping of the application state to some data structure, and the data
Yes.
structure isn't graphical right away. You're not directly right, like the cheapest possible immediate mode UI, you literally draw your rectangle when you say if button, right? You go
Yeah.
if button, and inside button they do a box and they do an if click.
Yeah.
As it gets more sophisticated, what you're actually doing is like, if button, if say you want to still write if button, but inside button what you're doing is you're generating a box and you're checking from previous frame, did we finish a click interaction at the end of the last frame for a box with the same
Yes.
identity as this one? And if we did, then we trigger it. And the reason we start changing it that way, right? The reason it's if button in the first place, for anyone who's listening who doesn't understand, is because of that idea that we want state updates to be sort of easy to implement. We want to be able to take um, and we want to be able to sort of implicitly combine together the description of the UI's layout and its the state updates that occur when you interact with it in one place. And that's easy if you can do if button, then block the results of clicking the button, right? Um, but then what you have to ask is, okay, if we're not actually generating the draw calls when we do if button, what's happening? Well, usually you're generating some kind of data structure that contains rectangles and strings, and later another pass is going to happen over that data structure, which combines it with the input data that you have in order to process like what things are getting clicked and what things need to be notified that they're being clicked next frame and stuff like that. Also processes, if you have an active text field, it processes the input text for that, and then you need to turn that same data structure into the graphics. And so there is totally a thing where you get the tree or the data structure of boxes, let's say, and you say draw this, and it just turns into graphics. But that is special case. So the question then is, do you want generalized graphical capabilities? Like, is it an operating system that allows me to open up an OpenGL context and run a game with graphics, or is it an operating system that is restricted to you have to display things that are like more like HTML like, right? Like here's a box, here's a
Yeah.
string inside it, here's the colors and the styles for everything. Maybe you can put a PNG in it or something, but if you wanted to actually use something like that for real-time graphics programs that were freeform that escape outside of the box model, you'd still need some way to just let them fill a buffer of their own,
Yeah,
right?
exactly. So I don't want to restrict it to that HTML. I mean, I would think they'd be two different subsystems, and I haven't really thought through on how to share, the graphics driver between the two. Um, so, um, but I wouldn't want to throw out like the idea, like throw out what I have with having the application be able to just arbitrarily draw whatever to the screen, provided it has the permission to do so. And I have ideas about permissions and all that stuff. But but I would want to have both. I would want like to write a simple application like HTML-esque, I guess. In this
Yeah.
case, um, uh, I would want that type of driver or subsystem or whatever. So yeah,
Yeah. Okay, so here's where my head is going with this. We could get into talking about more like if there's API design questions for immediate mode that you'd like to get into, because I didn't talk about the other bullet
yeah,
points that you had earlier yet. We could go there, but the burning question I have now is, okay, so the you're gonna have like an optional layer. It sounds like there's
yeah,
gonna be some kind of you can just draw to the screen thing, but then there's this sort of you do immediate mode API stuff, and then that gets converted into drawing to the screen. And my question is, what is the architecture you have in mind for that? And in particular, what I mean is like, since you're minimizing the kernel, I assume that means you don't want the kernel code to be the thing that takes in the boxes
correct,
and renders them.
correct,
So then, is each application basically calling like a user space library that is
pretty
standard to the
much,
operating system, but you're saying, hey, I built some boxes and I want to use the user space library for turning that into graphics?
pretty much. Yeah,
Yeah.
it's basically it would be like I'd probably have some sort of discovery service or something like that where you like the I'd have like types of subsystems or something like that, but Yeah, it would be you would pass this other user mode program, these widgets, and it actually doesn't have to know anything about immediate mode GUI at all. It shouldn't actually. It will. You just pass it like these widgets or boxes, and then it has. I haven't written anything more sophisticated than a simple frame buffer driver, but
Yeah.
um, it will take in these boxes and then just draw that to the frame buffer that the kernel already memory mapped into this subsystem. So,
Okay,
yeah,
so that's a little different than I'm getting a better picture now. So
okay, yeah,
it's not that if I'm writing a user space application that uses this immediate mode UI system, it's not like it's just a library that I use, right? It's not like I'm just creating the boxes and then in my own process doing the rendering. You're
correct.
picturing a single service that's a another user space process. It's
Yes,
implemented as another user space
yes,
process, but it's a single centralized service, and all of the different systems that want to use the UI system
yes,
are passing their data together to this one thing.
yes,
Okay, interesting. Can I pick at that a little? I'm
yes, absolutely.
curious why that's an architecture you would want, as opposed to having each process just render its boxes there with a function call.
So I think I thought of this actually because of window stacking, actually. Because um, yeah, it sounds a bit like Xserver. Yeah, hopefully, yeah. My intention is not to be as insane as Xserver, um, but um, I think. Hmm. I mean, that is a good question. I think it's because I feel there should be some sort of system that has knowledge of what is on the screen, because if it's just programs drawing to their subsection of the screen, they have like there's no there's no unified way of managing the GUI, if that makes sense. And by having a centralized system like that could enable that. But like thinking about it, like, do I have any examples or any ideas? I mean, the most obvious is window stacking, um, but and like window minimizing and stuff like that. But actually, maybe the application could just handle that, and then the only thing the Windows system, the graphics driver has to do is maybe like just by application stack the windows. It has nothing to do with the actual graphics on the screen. Maybe that's a better idea.
Yeah, so yeah, let me let me play with the idea for a minute and see what this sounds like to you. So the best the thing you could with an immediate mode UI system, and this is the thing that immediate mode UI systems are most often critiqued for, and it's not an entirely invalid critique, is that you end up building you end up doing more work building the UI. You end up spending more compute work specifically
Yes, that makes sense.
describing the UI. And the reason for this is like the whole idea of if you really get down into the like literal details of what is the data is actually doing, what the compute is actually doing, in a retained mode UI that is perfectly implemented,
Yeah.
every interaction is sort of doing a delta between the previous state of the UI.
Hmm.
It's a delta compressing everything all the time, right?
Yes.
And so you end up doing only the work necessary
Yes.
to go from a data structure that was correct before to a data structure that's correct now by mutating in place. You apply a delta to it. And if no change happens, no new work happens. If the change that happens is small, then most of the work that was already done gets reused. The problem, of course, is that this is much harder to maintain without bugs because, you know, highly optimized tight code that doesn't do too much extra work doesn't have resilience against tiny mistakes. If I only
Yes.
am correct, if I've accumulated all my deltas exactly correctly, and I have to write 1,000 lines of code that accumulate different types of deltas correctly across my UI implementation, then if one of them is wrong, then as soon as it gets into the wrong state, everything stops working forever. Whereas in a retained mode system, you can still have bugs in describing the transformation from the state to the final view of the UI, but those bugs will be persistent. Like they will consistent is probably the word I mean. They will
Yeah.
if you had a bug on something there, it's because of the state of the application, not because of a missed delta, right? The
Mm.
mapping itself contains the bug. It also makes this thing a lot easier to debug because a missed delta means you have to debug it by catching it the moment a mistake happens.
Yes.
Whereas when the behavior is consistent, a bug that happened on frame 10 happens again on frame 11, which just works nicely for debugging purposes. And when you have things that are when you have graphical applications that are like in a main loop, bugs are easier to catch when they happen over and over and over again once they start happening.
Yes.
If they are the kind of bug that can get lost 10 frames in the past,
Yeah.
that's where debugging becomes really tricky.
Yes, exactly.
So all of that to say, the downside is, even if you have a compositor that is doing the special work of not rendering twice, because the worst case scenario here, you got overlapping windows, right? You got two
Yes.
windows that they look like this, and this one behind does a bunch of graphics work,
Yeah.
and it costs a bunch of CPU, costs a bunch of compute,
Yes.
right? And then we cover it, and none of it gets seen anyways, right? It's like
Yeah.
half the
What are we
work that
doing?
got done was
Yeah.
redundant. No. And what you're talking about, I think, is throwing all of the UIs from the system into one handler, one process that will then do things like, okay, well, don't render any of this stuff because we're
Yeah.
covering all of that. You
Exactly.
can render
Exactly.
this, you can render all of this, but don't render the extra, right? And it can
Yes.
do that because it sees both things. Whereas this might be in one user space process, this might be in
Yes.
another user space process. They can't see each other. So this can't avoid doing the extra work.
Exactly.
And from the level of graphics, that is true and probably worthwhile. From the level of the immediate mode UI, that is, you still end up generating, right, in this covered spot, you still end up generating the boxes,
Yes.
right? You
At
still
least
end
the
up doing the compute
boxes.
work for boxes.
Yes.
Yeah. So that makes sense. I guess I'm still curious about the architecture there. If the goal is to avoid doing graphics work where eclipsing is happening, where eclipsing is happening is determined by the layout of the windows entirely, right? Like, I guess that's not
Yes.
entirely true.
Well.
If I have two separate data structures that are both describing a bunch of UI boxes,
Yes.
then I could find out that all of the UI boxes here are eclipsed by the fact that they're all behind. It's like they're in layer 10, and then there's a big window box here in layer 11, so all of those get eclipsed. But I think that since I don't think it's actually something you want to do on the this seems to me like the sort of thing where you want to think about like dirty rectangles or something, if you know what I mean. Like you have each window and you're trying to figure out which portion of this window is worth rendering, and maybe you're trying to use the data. I think I see what you're talking about. You're trying to use the data structure of the boxes, so
Yes.
the applications just generate all of the boxes. They
Yes.
generate
Pretty
all the
much.
boxes, and they don't need to know anything about
Yeah. The
other
graphics.
applications
Yes.
overlapping them, right?
Correct.
Once they've generated all the boxes, the part you're trying to save is don't bother going through and rendering
Yeah.
any of the boxes that are fully eclipsed.
Pretty much. Yeah. That would be a definite like win for something like
Yeah.
for something that like that system. And yeah.
So, can I pick your brain about another part? I have
Sure.
a question about how another thing works. So, if you have questions, we can make sure we're at like halfway through. If you want to switch to asking questions in 10 minutes about UI stuff, we could do that. Um,
Yeah.
but the last question I really want to figure out, and if you can answer for me, is I got distracted by the random spam in chat and forgot what I was going
Yeah,
to
yeah,
ask.
yeah, yeah.
Um, we were talking about the boxes, the
Yeah,
overlapping,
the
say rendering.
overlapping.
Okay, so yeah, I'm blanking now. I definitely had it. I think vaguely speaking, since I don't have a specific question anymore, vaguely speaking, the thing I'm not sure I understand is okay. Here's the specific question. What is the like is does the what is the ideal way for the operating system to structure the graphics of everything here, right? Like, are is the idea that you have a bunch of user space applications and it has to loop through each one? It's like the operating system thinks of a screen frame, and it's thinking like, okay, I'm doing a graphics loop, so let me go talk to each user space application and get each one to report back its boxes, and hopefully they all report back in time. And then once they all do, one by one get collected like that, we work with what we've got. Or does it have the is it possible for one application to be lagging and failing to, like, it's taking too much compute time to complete its
Yeah,
box
yeah,
tree, and
yeah.
so something reasonable happens? What like what how far like what how much of that are you thinking about? And
I feel there should be like yeah, the and then that's one thing is that I feel there has to be some sort of reasonable state in something like that where if a user application doesn't report its boxes in time before it draws the frame, like it has to retain the previous box. Like it has to because
yeah,
otherwise you get
yeah,
insane flickering. So
right,
um so I would assume that there would be probably some sort of UUID, unique ID or whatever.
yeah,
Um, and if yeah, I mean, like thinking about it, like how then does, well, actually, then it gets cleared on the next report, right? So it will keep the widget up
yeah,
until either the program closes or or um, or its next widget update or whatever per
yeah,
application.
yeah.
So
Okay.
or per IPC
um
box, yeah, channel.
so if I can re-articulate that back and make sure I'm fully getting the idea here, there's going to be this user space application that is responsible for the rendering
Yeah, it's a compositor, I guess.
of
That's
the
yeah,
rendering of the screen, and it's basically the compositor program,
yeah,
and it's going to have other programs, other user space processes
yeah,
are going to be running and sending to it either raw buffers or something like here's just my graphics that I want on this window, or it's going to be like here's a like here's the um, UI box system that I want for to be filling my window right now, or maybe even a combination of those. Right, a very common thing in a lot of these is like you sometimes want a certain box to just say, "Hey, I am just going to be like draw commands that
yeah,
like I just want to have a box here where I can just do arbitrary graphics, like set up a gradient or something. Right? A
yeah,
color picker is a good example where you kind of want to just arrest control back from the UI system and draw something arbitrary
yes.
inside of one of the UI elements. So that's an interesting piece too, where it's like maybe you're sending buffers or draw command buffers or
Yeah,
something
yeah.
that are
Instead of
received.
frame bu yeah, I'm not so great with like the with any of the graphics APIs, but yeah, like I think of it like, as a simple thing, it would be like a frame buffer, and obviously it would be you would change that to a draw command once you actually
Yeah,
have 3D
yeah,
graphics API. Yes.
yeah. Okay, so the way I'm imagining that working then is that program is keeping track of there's sort of a stateful sense in which other processes come in and say, can I get a new window, and get back a window, and then say, hey, for this window that I've got, I'd
Yeah.
like to put this system of boxes or these graphics there. and whatever has most recently been sent is the thing that that program is going to remember. Like
Yeah,
that program is
exactly.
remembering
Yeah,
state for each of the windows,
correct.
and then its job is to efficiently piece all that together onto the screen every frame.
Yes, exactly.
Okay. Okay. Yeah. Okay. I think I get that.
Cool.
I think I'm out of questions for now.
Okay, awesome.
So if
So,
you've got some questions, go for it.
yeah, awesome. So, okay, so what did I have? So we had, so I guess, I feel let's start with these 'cause I feel this is like very trivial and like who cares type question. Or maybe these three. It's like who care? Like I feel this is kind of simple. Um, because it probably doesn't matter one way or the other. So for like global state, like I don't know. I feel this is like something I always go back and forth, and maybe it's more of a programming thing versus a GUI thing, a Mimo GUI thing. But like I have literally wait, where is it? I am GUI. If we go up here, these all structs. Do I have? Yeah. Um, okay, like I have like just literally like a thread local global. Actually, this is actually a good question because I made this thread local just because of I guess the way I'm changing it. I don't think it will remain a thread local, but I don't know how. I'd imagine that this shouldn't remain a thread local for a global state for GUI. But I don't know if you've actually seen something like
What's
this.
what's in the thread local exactly? Like, is this the
So
whole
this is the
UI
whole
system?
UI state, everything. So this is
Okay.
all of the block map and everything, and
Yeah. And so this goes and lives inside of, is this the compositor program, or is this like a library that each user space program is
this
filling
would
its?
be a library. This would be part of the
Okay.
library.
Okay. And let me think. The library is providing the, hey, here's a thread local UI state.
Yeah,
I think that what, like, the way I would tend to structure an API, now this is again this, it's a little different. Like every context matters. When I
yeah,
tend to write a medium mode UI system, I tend to write it as if it is directly serving the main program. So
yeah,
it's not usually the case that I'm creating a reusable one, which is what you're doing. So that is a difference in context that
yeah.
is
That
going to
is
be
true. Okay.
important.
Yes.
But I generally don't feel the need to put the UI state in any kind of global slash thread local, which is very similar to a global in a lot of ways. Um, the thing I would usually do is have it be explicitly passed through. So I would have it be constructed by the top level usage code, and then I would have that pass through. Now I might, in the program itself, I might decide to make that a global because that's the easiest way to
Yeah,
pass something through, but I wouldn't in the UI layer do that. I would say the UI layer thinks it's going to get its UI state as a parameter to all the functions, but that's just, I know there's also, that's like a very C thing. I don't know if like the Zig, I know Odin does the like context struct stuff. I don't know if Zig does the same thing
no,
or if
no.
it's all through
There's
thread
no
locals.
there's
Yeah.
no like built-in language support for like a context.
Gotcha. So yeah, in that case, thread local is a very similar kind of tool. Like it lets you say, here's something that's going to exist in my threads. And so I think that it's a similar mental model of like, you could say, hey, the way that the library works is you select in a specific UI state, and then all the APIs that modify a UI state are modifying whichever one is selected into the thread local. And that's kind of what you've got, it looks like. Um,
Yeah.
but there's also probably just one. Like you're not imagining two or three different UI state
Not
structures being
really.
built,
No.
right? Yeah.
But so I guess what you would do, you would like with this, like with a begin window, um, you would you would actually pass in the whole UI state in
Yeah.
each every
And
call.
let me tell you a little, like, here's a pitch for why I think that this is something you want to, which is sooner or later when I'm developing programs with graphical applications, for like graphical applications, just on Windows or whatever, the having a single window stops being good enough. Like, a lot of times, as they get really
Yes.
big and useful, once they become really big, hefty, useful tools, you're like sitting on a multi-monitor setup, and just once in a while, you wish you could put a window on both screens. You wish you could have the same process controlling multiple windows, right? And at that point, and they might not even be on the same thread, right? It's just going to be like we got one thread, we're going through both windows or all of our windows and filling them out, and yeah, maybe that's not going to be fast enough, and maybe we got to talk about like putting them on separate threads. But I don't want to think about that on day one. I want to just say, like, all right, what is it like to have two windows? Can I have my main thread run the updates for all of them? And I mean, I don't know that this is necessary. In theory, you could have the UI state just be kind of like um a data structure that can span as many windows as the process has created, and each box is assigned to one of the windows, but the data structure itself spans them. Or you could arrange this so that each window contains within it one complete UI system. And then
Yes.
I need the ability to say, okay, as I'm creating more windows, I create more UI systems, and I manually or with some kind of helper am saying, okay, while I'm rendering to this window, make sure I'm attaching everything to this UI system, and then submitting that UI system through that window to the compositor. And when a different window is in the same process, so basically what I'm saying is, if I make a process with two windows, or with multiple windows, I still expect the compositor, whatever's providing windowing in
Yeah.
the base layer of the operating system, so to speak, not base layer in my sense, but like in the in the in the
Kernel. Yeah.
in the ecosystem that sets up the idea of multiple windows, I would want my two windows to go through that. I wouldn't want to have to write my own windowing system every time I want two windows in my process, right?
Mm, yes. Okay, so do you actually have like begin window and then at some point there's a Win32 create window that like happens in here?
Yeah. Yeah,
Okay.
so my code would do like I would do like, I have an abstraction for it that's OS create window, and then underneath that
Yeah.
it's create window W or whatever for the Windows version. And I would just like a default application with one window does one create window call. It's like OS create
Yeah.
window happens once, and you just do everything on that. But as it gets more sophisticated, you might say like, okay, we start off with one, and then if someone ever hits the new window command,
Yeah.
then like it spawns another one. And if anyone ever closes a window, we close that one and we check if there are any open windows left. And so again, remember, we are thinking about who is controlling what data a little bit. The window compositor is controlling where each window is. At least in Windows, the way it's structured is the window compositor lives outside of my process.
Hmm.
It decides things like where the window is and how big it is. I ask where it is. I
Yeah.
can I can make requests to move it with my code, but the user can also click and drag it and resize it. And so I don't get to say where it is and how big it
Yes.
is. It tells me, and its job is to handle all the user inputs that would change the size and scale of the window, right? So responsibility for sizing and scaling windows is outside of my process, and there's kind of this retained mode relationship here,
Yes.
where I said create window, and somewhere else that's a data structure, and I have to ask where is the window. And this has to be this way as far as I know, because of the fact that we want multiple processes that may not be able to talk to each other directly to all nevertheless share the same screen. And so we need a someone else outside of all of those processes that
Mm.
sets the standard of how windows behave.
Okay. So you would have um all this to say like the begin window would have like the UI state you know you would create so like this I am GUI init this would return like a UI state and you would have like more than one per process or something like that?
That's how I would. I think I would probably build it that way myself. Again, I don't know
Yeah, yeah,
exactly what's in your data structure, but I think that that's the way I would think about it because it seems to me like your UI system is basically it's the context data structure, and a part of what it's doing is helping to aid in the construction of the UI. But the other part of what it's doing is it contains the UI box data structure, right? So there's like the data structure we submit might not be the whole context, but it's some sub part of the context, right? So there's somewhere inside the UI system is the UI data that the compositor needs to know about.
yes,
And so if I'm understanding that correctly, then I would think that if the point is to have a one-to-one relationship between user windows and UI systems, then I would want to not have a thread local for my UI system. I would want explicit parameters and I would want to create them. But that's how I would do it for
yeah,
myself when I'm not creating a library that others have to use.
yeah. No, it's
If it had to be a library for others to use, you could imagine like saying like, well, maybe that's the right architecture. We're going to hide it all in the API so that you only ever see a window. You don't see a UI system or something like that.
yeah. It could be wrapped like that.
Yeah.
Yeah. So, but that's something to consider. I think I haven't gotten. I think the reason why, honestly, I think the reason why it's a global is because I haven't ran into a case where I needed it to be more than one.
Yeah.
So, and the only reason it's thread local is because it's just like it's a transition period. And so
Yeah.
like, but yeah. So okay, cool. So let me write that down. So like global state. Yeah, probably want to consider uh, passing in state as a parameter. I haven't for my use case. I don't off the top of my head think know of when I would want this right this second, but I'm sure at some point that will happen. So that's actually just a good hint to the future that probably at some point I'm going to hit something where I'm going to want a a parameter for the UI state. So that makes sense. Cool. Uh,
I mean, the alternative, like you could do it the OpenGL way on Windows, where it is a thread local pointer, but you have a way to bind it. So you can say like,
yeah,
okay, begin window binds the UI system for that window, and then it's always implicit. I love going explicit all the time, but I do know that like as you go to create APIs, like the process of presenting an API to someone else
is that yeah,
that needs to, especially one that needs to be used by everyone at like every level of complexity, the simplest little processes to the most complex ones. Sometimes, at least in theory, it makes sense to think about it other ways. So I
yeah.
don't know. Yeah.
Yeah, that makes sense. I mean, like the most basic thing I think of is like arenas. Like I used to
Yeah.
have uh like the data structures hold the arenas, and now I actually think it's better just to pass them in explicitly.
Mm-hmm.
But it does complicate the API because now you have an extra
Yeah.
parameter. So, but anyway,
Yeah.
cool. Floating point versus integer. I think we always want floating point, right? Like typically,
Yeah.
like
So that's what I've always understood too. The Windows API will give you integer based coordinates for the
yes,
pixels. And that means here's the consequence of that. That
yeah,
means that if you have a window, it is always snapped to the
yes,
pixel grid, right? Your window can never be half a pixel to the right or something
correct.
like that. There's just not a thing. Now, within the context of like game programming, or if you're doing like high fidelity text rendering and stuff, then anti-aliasing is a topic you get into and you figure out how to make things look good when you are positioning them at or coordinates of a fractional portions of a pixel, right?
Yes.
I don't see any reason why an operating system couldn't be doing that too. Like, there's no reason why you couldn't get into the anti-aliasing problem and say, okay, this window is half a pixel over, which means whatever box they put here covers half the pixel, and the whole compositor is going to anti-alias it, and that could be really cool. or it could be a lot of complexity for nothing that doesn't
Yeah,
work out. Like
like
that's hard. That's a hard call to make.
smoothing.
But I
Yeah.
think, but I think, I mean, you're doing an experimental OS. I think it'd be cool to do all floats for like your window coordinates and
Yeah,
see if the anti-aliasing can be solved.
I agree. I have everything as floating point for the UI system, but
Yeah,
when rendering to the screen, everything gets converted into integers for
yeah,
efficiency reasons, and
yeah.
especially with the alpha blending and all that stuff.
Yep.
Um,
Makes sense.
cool.
So yeah, I think you do all floats. That definitely isn't a problem. There are times when you're building a UI when like text gets all blurry because it's half a pixel positioned,
Oh, okay.
and that's usually not hard to solve. You just put a floor in. Like you can use floats and still get
Yeah.
integer alignment when that is important. Because integer alignment is nice for like if whenever something is moving smoothly, integer fractional pixels are nice. Whenever something is sitting still, integer alignment is nice,
Okay.
and
That.
you can
Yeah.
get both from floats.
Cool.
So
Yeah, that makes
yeah.
sense. Awesome. Vectors versus scalars. So right now my API is just scalars, though around my code base for BoksOS, I've started using vectors for especially for the rendering stuff.
Mm-hmm.
But um, I don't know if this is more of a personal preference thing or not.
It's a great question. I don't know either, and it's hard to think of how you would measure something like that. I think, and another thing that's interesting here is I don't know what Zig. I think Zig does some optimizations that don't happen in C. So like struct passing in C, if you have a if you have a four float vector that's RGBA vector or a four float rectangle that's not x0 y0 x1 y1 kind of rectangle. Um, if you pass one of those structs as a struct, it has to copy that on the stack. Like it has to take your struct, make a memory reservation on the caller side, copy into that block, and then give a pointer to that copy to the callee. And it has to
Oh,
do that because C gives
yeah.
you guarantees that if I pass something as a value, that it won't be modified by the callee.
Would
Right.
it
So if
be
I
passed
call,
by registers? Because I know the ABI.
yeah.
Uh, okay.
So if I give you a struct with four floats
Yeah.
and I put it in my first parameter, what's going to happen is the stack is going to contain a copy of the four floats I'm passing, and then the first register in the ABI is going to contain a pointer onto that position of the stack.
Okay. I actually did.
Right?
I thought for some reason I thought it would unpack it, but yeah, no, that makes more sense.
No, it
Yeah.
doesn't do that.
Yeah.
It does. That's not the way. At least that's not
No, that
the
makes more
API
sense.
definition on
Way.
Windows or
Yeah.
Linux.
Yeah.
Yeah. This is why if you can pass things by pointers, even if you're not modifying them, it can be valuable because you are giving it permission not to make the extra copy. Of course, then the signature, the cool thing about making the extra copy is that 100% guarantees if you're calling an unknown foreign function, you didn't write the code, it's in a DLL, it's in some other person's
Yes.
code, and you don't have the source code. Then if you want to be sure that they're not modifying the thing you're passing them, you have to make a copy before you pass. Because if you give a pointer to your copy and you don't know what the code is doing, anything could happen, right? I mean, they
Yeah.
could still
Yeah. Of
modify
course.
your thing if they're willing to hack the stack and like really go
Yeah.
nuts.
Of course.
But like, but you get these layers of plausibility. It's a lot less plausible that there will be accidental mutations to your struct if you make a copy of it and pass it first.
Correct.
But C doesn't give you a way to sort of semantically say, I want something that looks like struct passing, but that is optimized like a pointer. You either write the signature in a way that says this thing could be modified because it's a pointer, or this thing is copied because it's not a pointer. I'm guessing that languages like Zig do
Yeah.
smarter stuff to optimize that. So
Zig actually has a built-in vector type, so it will
nice,
pass. It will pass things on the YMM registers.
nice,
Yeah.
yeah.
So
Um, that's cool. Let me think. My answer, if that's the case, my answer is to use the vector types.
okay, that makes more sense. Yeah, I was thinking that actually. Okay, cool. Yeah, because it just maps to the hardware a lot. It's just like
Yeah,
C is
yeah.
bad with that, I
I
guess.
also I also like that better. Like APIs that set up a language of vectors and ranges. Like basically, vectors and intervals are the interesting thing. If you and the reason interval is cool is because a rectangle is technically a pair of intervals from one perspective,
Mm,
right? It's a pair of ranges for an x-axis and a y-axis, and so being able to bundle those into types that are sort of create a language for the API to speak are nice anyways. Like that's my preference. I don't like to have to write out three floats. Like I don't want to have to write color.r, color.g, color.b when I've packed my color into a vector, right? So
yeah.
um,
Yeah, no, that
I
makes
definitely prefer it that way. I think that's a more modern, typical way of doing things. And if that enables potential optimizations, even more reason.
okay, awesome. So I'll definitely take uh, I'll definitely go with vectors then. Awesome. And then I think then the final thing before we wrap up is I guess the default strictness. So I think I was running into some like weird issues, like where like I think I had default strictness as 0, and then like things just got squished, and then I had default strictness of 1, and then like the window became way too big, and like I don't know if you have. I mean, I guess if you go by ZII, it's like it's always going to just be 0. But I don't know if you have like a preference for or having came across. So
Yeah.
yeah.
Um, so it's gonna be hard for me to say. I actually don't use because I know you got the system from Ryan, and it's a really good system for dynamic. Like the system that's presented in Ryan's posts
Mm,
gives you like a box language for generating lots of common UI layouts, right? You can like create some columns, create some padding that's flexible. Like you can let some of your columns flex and others are fixed with like checkboxes don't need more space if the window is wider. They're the same width no matter what, but text fields let them stretch, right?
yeah.
And so what's the correct default strictness? I don't know. I think the answer maybe the answer should be nan. Maybe you should not rely on a default strictness. Like
Yeah,
maybe
that
there it should
probably.
be considered like bad usage form to not always specify it explicitly. If I was gonna say something, I'd say yeah, just let ZII do it because if everything is kind of busted, then you are gonna no default is gonna get everything right, right? That's kind of what you were
Yes.
saying. Is like when I make it 0, this busts. When I make it 1, this
Yeah.
busts. So let it be 0
Yes.
because ZII, and then get into the discipline, set up the API to make it as easy as possible to always be not relying on the default.
That makes sense. Awesome. Cool. Or um, so I think the way I have it, and so Zig has by strongly encourages um initializing your structs, and so if you don't like Zig supports default was it default fields. Um, so if we go to I am GUI, you can see like I just like have a default field. But if you get rid of it, then it will actually it will throw a compile error. Um, I feel that that's probably okay. Um, I mean, like I don't know. I haven't really had like a strong opinion one way or the other if like ZII is like always 100% like what you want all the time, or maybe there's some cases where
So I'm going to give you the best argument I've got for ZII being the right thing to do always.
okay,
It's not necessarily the best. Um, there's a couple things here. I use C most often, so
yes,
it works
it's
best in
very
C
easy for
because
C.
yeah,
Yes,
in C anything besides ZII is a lot harder to achieve.
exactly.
Actually, like since there's no support for anything but ZII, and ZII support just is like it's just like you do curly bracket 0 curly bracket is the syntax for please zero initialize this. There's no way to say force to
Yeah, exactly.
the easiest thing in C is not uninitialized data, and that's a nightmare. So ZII is a cure for a problem in C, not a feature of C. But ZII is also a feature of memory allocation
Yeah,
defaults.
yeah, exactly.
So if I have an arena based code base and I'm grabbing several pages of data
It'll be
of memory
zeroed.
for the first
Yeah,
time, that's all going to be zeroed.
yeah,
If that is means it's already initialized, that's really cool, right? And so if your designs go against this, like you design types
yeah,
that aren't ZII'd, then those types, as soon as you semantically in the language's perspective bring them into existence, work has to be done. Whereas if there's ZII, now I don't know what Zig does. Zig probably doesn't actually take advantage of this. It's not like Zig can go, oh, I see that this struct has zero in all of its
no,
fields, and I see
yeah.
that this memory was just malloc or just virtual allocked. Therefore, it doesn't need to do any work. It doesn't know that, so it still has to put zeros in where there already are zeros. So I don't know if this is a win you can get in Zig. The fact that C does non-initialization as the default means that when you have a page full of zeros, you get free zero initialization, whereas you would have to work to get your zero initialization
So
for free.
I don't know. Hmm. I'm trying to
I
think.
don't know.
Yeah, I mean, so like, wait, what is the optimization that C can do? What is that again?
So since C does not, like, if I say, hey, this structure here, this pointer here points to this struct type, and I or like say I've got this might only apply to locals. I don't know what Zig is doing with those default fields. So say I gave you a block of data that was all zeros, and you took a pointer into the middle of the data and said this, like, here is the beginning of my state struct or
Yeah,
whatever.
sure.
I'm imagining Zig in that case isn't going to go fill in all of the fields. There's no new, right. There's no like new
Yeah, exactly.
placement
No,
or
no,
anything like
no, no.
that.
You can absolutely, and I do it all the time. You
Yeah,
absolutely can cast an integer to a or a slice of data into any structure you want, and it won't do
yeah,
anything.
right. So the only time it does something is when you're making a local actual variable of that type. Right? If you make a
Yeah,
struct of type state, then it's going to initialize the stack memory from the defaults. Right? It's
yeah.
doing that
Unless
kind
you
of thing.
use the undefined. There's an
Yeah,
undefined
got it.
keyword. So,
Yeah. So I think,
which I
again, I think that the defaults should be zero,
yeah,
because if you ever take a pointer to the data
yeah, exactly.
in a zeroed buffer, yeah, it's just,
Yeah,
I think
no, it
it should
makes
always be
sense.
zero. Anytime it's not zero, you're specifically saying like there needs to be like an initialization phase that the user engages in to get this up and running. Maybe they engage with it using the language helpers, but like I don't know. I really
Yeah,
like it.
I think
It
like
seems to be good.
I've like thinking about it more. Like I think like I typically do zero initialization. Like it's like typically I do add zeros to the
Yeah,
fields, but if there is a field that like actually really does shouldn't like like I know like you should always make sure you handle zero, but like
yeah,
if if there is like a field that like should it really be zero? Like, there's no reason for it to be zero. Like,
yeah.
then I'll do
I,
that.
Yeah, so I think like there are definitely times when zero initialization just doesn't work quite right.
Yeah,
Like
exactly.
I wish I could think of a good example of this. Like if a common thing that I run into is like slightly more interesting compound data structures
Yeah,
start leading
exactly.
into places where you have like, okay, when I create this data structure, I tell it, we're making a hash table and I'm telling it how many slots to have. Well, the pointer to the buffer can't be null. It
Yeah,
has to, like, I need to, the whole point is to allocate the slots,
yeah,
and the slots can all be null, but the pointer itself needs to be initialized. And so
yes, exactly.
there is such a thing as like the useful way to initialize a thing is not always to zero out all of it
Yeah,
out front,
exactly.
because sometimes you want an API where you put in some initialization parameters, you get it set up
Exactly.
correctly. I think that's all reasonable. I think what I'm mostly getting at is when it comes down to like numerical fields, if zero
Yeah,
is valid, then letting
use.
that be a default seems good. The only time that I think zero not being the default should even be considered is if zero, it's like this is going to lead to division by zero, and yes, we should go and guard by against the division by zero, but there's no useful world where this is a zero, and so we should look for the convenience of an initializer that doesn't do it that way. Makes sense. Like
Yeah.
somewhere you need to encode how you initialize a sane default.
Yeah, so that makes sense. I will say there is one case I've ran into where, to me, most people don't do it this way, but Zig, I think, is nice enough where it does it. There are hardware registers that have to be one.
Mm,
And so, like, if I have like a structure that that maps onto that hardware register, like I'm gonna set that to one because like there's no reason for that to ever be zero because that's what the spec says. But yeah, in general, it's always like I've always seen like either like it's kind of fuzzy and then you have to kind of really initialize it, or just use zero. So cool. Um, but trying to think, is there? Let me just like take a look.
so I also had a list here. I know you have your list. Let me
Yeah,
double check. So we have 30 minutes or so
yeah,
to try
exactly.
to chat about this still. We talked about window stacking, which is something we talked about before. Do you mind if I bring up some of the other things we had thought about talking about?
Yes, absolutely.
So at one point, and I don't actually know what this note means anymore. So maybe we have to figure out what this note means. But we were talking about the IM GUI like architecture possibilities, and uh, my note says stack parameters. I don't know if that sounds familiar
Oh
to
yeah,
you.
yeah, yeah. So, um, I know like this is I don't know how this is what Ryan does. Like I don't know how common it is, but like is having more a stateful API with
Yep.
stacks and like
Yeah.
having some sort of context structure with that.
Yeah.
Um, I guess the question was when do you decide if something is like part of the API? I guess this is more of an API question versus
Yeah.
like
Okay.
I am GUI question, but
Yeah. Yeah.
yeah. So
Okay, so what's happening there is interesting. This is why you have the struct called UI state somewhere, right? So we
yeah,
were talking about it's in a thread local, and I was trying to emphasize that that thing, it doesn't necessarily have to be that that whole thing needs to go to the compositor. It contains within the UI state the core data structure that does need to go to the compositor, but it also contains sort of, I don't know if you want to call them scaffolding
yeah,
data structures or helper data structures or constructor data structures, but there's other data structures that are a part of this. They might be API support data structures, right? So something like this. And the point is those things can be very useful for things like, okay, let's take a step back and do a similar, I am not immediate mode UIs, but just immediate mode graphics, where you do things like, um, you want to put a triangle on the screen. An immediate mode version of that is you just go draw a triangle, you give it 3 points in a color, and you got a triangle, right? It's like that's it. There's nothing more to it. Now that sounds like, isn't that what graphics APIs are? Not necessarily.
no,
People used to do
yeah,
retain mode graphics APIs where you would construct a triangle object and submit this to a
yeah,
render function later to figure out how to turn that into pixels. The immediate mode version is just, well, write the function that does draw a triangle that you can call, and if you're software rasterizing, then that maybe just goes and fills in pixels. If you're using a graphics API, maybe that calls the draw function on the graphics API. Or if you're doing something more sophisticated, maybe you are buffering up geometry and you're going to submit all the geometry later. But the point is, the API is no longer construct triangle and attach it to the graph. The API is draw a triangle. And so your API, the interface you get to use as the programmer, looks immediate mode. Right? It's an
yeah,
API structuring question. And then um, the same thing is happening with um, an immediate mode UI. You want that, but with that draw a triangle, something that gets annoying, that gets even worse, much worse in a UI immediate mode UI, is that the number of parameters you have to pass starts to get to be a lot, right? If I have
Yeah.
to pass 3 points and a color for each point, you start getting this feeling of like, oh, okay,
Yeah.
this is what? This is 6 parameters for one triangle every time, and like, and maybe it's in a loop, hopefully, or like something that's like you can pack it, you can get it done once, and it's good. But if you're just trying to put 10 triangles on the screen, that's like 60 parameters you're typing out, and so you start wanting to do things like, okay, you know what? Can I just say, instead of drawing a triangle, I'm going to say set color, and then I'm going to say here's a vertex, set a color, here's a vertex, and right, so you get like this idea of set color is no longer an immediate mode API, right? What that is a context API. That is saying in the current context, set the color that it like set a color, and then when I create a vertex, attach that color to the vertex, right? So
Yeah.
we have our parameters are no longer listed in one big call. They're all most of the parameters, little by little, are getting stored into the context. And whenever we
Yes.
do a call, all of the parameters that are missing from the call are just being grabbed as defaults from the context,
Text. Yeah, that
right?
makes sense.
And then you are setting the context. So when you were earlier talking about the default strictness, what I'm assuming is that like default strictness should be easy to control without having to set default strictness on every single box,
Yeah,
right?
exactly.
I
No.
should be able to make default strictness explicit without having to manually specify a default strictness, especially because if you look at what goes into a UI box parameters, there's strictness, there's color, there's string, there's a bunch of stuff you might put onto boxes depending on what kind of system you're going with. And you kind of want to get to a point where you're just saying I am GUI underscore box, and you give it some coordinates, and then hopefully that's it. And the rest of it, maybe you give it some coordinates and an ID or something. There's a few things you give it, but you want a lot of it to be pulled off of context. And then you have these context APIs. They're modifying the context. It's not the same thing as retained mode because you're not constructing objects and piecing them together. You're just it's a stateful modification of the context
Yeah.
as a way to ease parameter passing
Parameter
complexity.
passing. Yeah.
Yeah.
That,
Um, so the stack is a more sophisticated way of doing that. It's a way of saying, hey, I very often find that I have a context like this, and then I want to say, okay, for the next few things, I want to make text white. And I want to be able to write that in such a way that I can reuse it, right? I want to be able to make blue panels and green panels and red panels. And occasionally I want to put this widget in there where the text has to be white. But then I want to return back to the original color. I want my helper to be written in such a way that it works in all contexts, but it can't therefore say, well, after you're done with white text, the helper returns the text color to blue, because that only works if the text color was blue before, right? That
yeah.
only works in a certain context. So the whole point of the stack is just as a more complex support data structure for the context manipulation, that context parameter passing. Is it good? I think it's very good for UIs if you follow closely the way Ryan does it. Because it does have the property that then you can start doing like, okay, this box is going to have a specific strictness and then back to the default, and this box is going to have a specific strictness, and then this entire set of boxes. Oh, I take all these boxes and do a push on the color parameter and a pop on the color parameter or whatever. Um, I don't think you have to do things that way.
Yeah.
Another option is instead of
Struct.
containing a stack in your structure, you can write helpers. This is the way I tend to do it. Is I use the call stack as the stack. So I will do something like, um, if I want to change the current color, or another good example of this is a clip rectangle. A lot of times you want a clip rectangle. So when you're, in addition to sending down boxes, you say like, here's the current clip rectangle. So if I have text, all of the things I'm sending are also clipped to this range right now, right? And so you set that it's in the context. It's just each thing has its own clip rectangle, but you just set it once, and then 100 things all have the same clip rectangle,
Yes.
and it creates the effect of them all clipping together as if they're being contained inside of a space. And so what I will have in my APIs is usually I will have like a set clip function, which takes in a rectangle and it returns the previous value of the rectangle, and then a restore clip, which will take that in at the end. So I can do
Uh,
like my function stack contains the restore rather than having an actual internal data structure. The downside to that is you have to write more code, right? You have to write
yeah.
restore type foo equals set, and then at the bottom restore foo, instead of push pop. and just
Yeah.
name the stack, or name the variable channel that you're modifying, right? You have to carry that, like, that connecting piece across it. So there's a little more opportunity for API usage mistakes there,
Yeah.
but it
Okay.
also means you don't need an internal data
Structure.
structure. Yeah.
Yeah. And I think for the longest time, I did like when I was writing the operating system, I didn't have thread level storage, and um, so like I feel like I would have like done things that way, but like yeah, I guess also like but yeah, I think I do like the per parameters. Like I also don't know. I mean, there's sometimes like there's the per parameter stack, and then there's also like push an entire struct onto as a context. Like
Yeah.
I guess it really just depends on the API whether what depending.
So yeah, what you want to do there is, it's not, if you're gonna go with with a data structure like a stack to handle all this,
Yeah,
you're not. Remember, this is the purpose of this data structure isn't to be an efficient data structure or to store data compactly or anything like that.
yeah,
The purpose of it is to enable a particular API pattern to work.
yes, correct.
And so the question then is like, okay, are you willing to have, like, if it's an independent stack, you got a stack of v4s, four float vectors for your colors, and a stack of rectangles for your clip rectangles. And if it's separate ones for each one, whether or not that's the right call has to do with whether or not you are finding it easy to express your UIs correctly, intuitively with the API. And if you find that it's like, oh, this is making it so that I'm constantly forgetting to pop one of the five things, then I have a bug and it's wrong, then maybe that's not the API you want. And if the
Yeah,
API you want then becomes like, oh, I need to do a push and then set parameter, set parameter, set parameter, and then pop, that's the API you want. That doesn't have to be an internal stack push and a pop. Maybe you can optimize that in different ways. Maybe a
yeah,
push sets a counter, and then whenever you set a thing, you say, oh, the counter for this is older than the counter of the most recent. Like, you can imagine playing with the internal data structure to get the right optimization out of it. But the point is, if you're doing the thing where your internal data structure is this sort of scaffolding constructor helper data structure, then it serves the API. And as much as possible, you're looking for an API that is super easy. Now, the other philosophy can be, I'm looking for efficiency here. I don't want, I'm not going to take on any helper APIs that are convenient if it's going to require big
memory.
memory intensive data structures internally. You make the user's life harder, but you make it possible for them to go faster. So
Yeah, I guess that is a trade-off. And, like you could have both APIs too.
yeah, yeah,
Um,
right.
oh, if you have something to say, I have a
Yeah, I was gonna say, ultimately it's just about, can the user construct what they want. If they can't construct it fast enough, if you write the really great API that's super expressive and you can express what you want correctly most of the time in an intuitive way, lots of people will use that. But if it ever isn't fast enough, then fixing that is just a matter of building a custom, finely tuned constructor for the same data structure that you're trying to build. Like, either way, without the helper API, ultimately, since you're not making a function call interface, you're making a data protocol interface.
yes,
So all I have to do, if my code isn't fast enough using your library, is to figure out how to construct the same data structure in a
correct.
fast way.
Okay, and then I guess my final question with this is that what like with API design, what how would you determine if something goes into like a context versus an actual parameter in the function?
Okay, what I would do personally, if I wanted to be sure I was, so a lot of times this is gut feeling stuff,
Yeah,
and you iterate on it. You go like, hey, I've written five things with this now, and I keep making this one mistake. I think I'm gonna try it a different way. And then, of course, the worst thing is you make tweaks to your API and you don't get a chance to use them again. Like, you build five things on an API, you learn the API is a little busted, you fix it, but you don't have five more things to build, and so you don't get to see if your fix works, because the test for an API change is the workflow that it creates, not anything, nothing else, right? Like,
yes,
ultimately, as long as the API is capable of making the system work correctly somehow, it meets that bar, then the only thing you're tweaking is how often you get it right on your first time, or how many
yeah,
times it takes to get it right, something like that. Um, And that means you need to really actually develop on a new API to see if it's any good every time you make one. And if you're making a new API, but then you're just refactoring to it, then you should have a little red flag go off as like, I haven't built something new on top of this. I don't actually know what the development process is like. I just know what it's like to refactor onto this thing. That's different.
Yeah. Oh, okay.
Um, then the other thing to pay attention to, and that's really annoying because sometimes you just don't have any good excuse for building yet another thing on top of the
Yeah.
system you're making, right? But you know there's a problem with what you've got, and then you can get a little stuck. I think sometimes being willing to rewrite also helps there. Like you go, you know what? I think the API is wrong, so I'm gonna just rebuild from scratch 2 of the 5 widgets on the new API. That way I can feel it.
Yeah. That makes
That's
sense.
a way to do that. The to answer your question though, if you're not looking for, or to answer your question in a very literal way, if you're not comfortable with a gut feeling approach, and you're not comfortable with and it's not super easy to just find how you're going to iterate, because there's a sort of back and forth process that can happen where you make a guess, you use it, you learn, you improve the guess, and then you rewrite the thing until the rewriting feels so good and fluid that you don't feel the need to ping pong anymore. If I were going to try to come up with a formula for getting pretty good first guesses, it would look like this. Look at a bunch of examples of the operations, not the, or eliminate set context entirely, make all parameters explicit. Big pain in the butt to actually write code to it now, but look at what all the parameters need to be. When you're putting down a box, what are all the parameters? You're putting down something other than, like, if there are other types of operations that are core to building the box data structure, like the larger collection of boxes, whatever, like the nesting needs to be and stuff, right? Whatever functions you need with all their parameters. If there are multiple functions, then what you're looking at are, what are the parameters that all of these have in common, right? That's my most
Yes.
likely guess
That makes
for
sense.
what's happening, especially if they all have it in common, not just in the sense that they all have it in common in their signature, but in my usage code of this big harness API, I'm passing the same thing to all of them, right?
Yeah.
If I made it raw and I see like, oh, here are 5 calls in a row where I pass the same color. Clue, maybe colors tend to correlate locally, so that'd be a good one to pull out and
Yeah.
make a context variable for. If position happens to change, just like every button's in a different position, it wouldn't make a lot of sense for that to go into the context anymore, right? So it's about like looking at where you're deduplicating parameter passing, basically.
Yes. That makes sense. It's it's really just like start off with like the simplest thing, which is
Yeah,
like making everything a parameter, and then just kind of refactor out
yeah,
and pattern match and stuff like that. That makes sense.
yeah.
And also the gut feeling thing is also like a um, that's also perfectly fine. In fact, like I would
Cool.
say, oh sorry, um,
I ain't got it. Go ahead.
oh I would say that like I feel like a gut feeling like if the answer it's a gut feeling, then like I'm actually okay with that because it's like kind of like just like an experience thing that you just like
Yeah,
develop over time. But yeah,
yeah. Yeah, I think it's an experience thing. It's also a taste thing. A lot of times,
yeah,
sometimes people like, some folks will write functions with 10 parameters and like feel that that is the appropriate API, and
yeah.
other people need to get it down to 3 and put everything else in a bundle or in a context or something.
That makes sense. Awesome.
Yeah.
Okay, so we are approaching 7:30. So I think I have all my points good. This was a great conversation. But if you have anything else to say, we can take one more thing.
Sure. Let me think. Um, Off the top of my head, I don't have anything immediately coming up. I think from now that I understand your architecture better, I'm coming to understand that your problem is just a classic IM GUI design problem. Like, there's nothing about your context where the IM GUI is actually different, which was something I wasn't clear on
Okay.
before today. So it's good to know that, and I think that means if you go, one useful exercise that's popping in my head might be to go and use existing IM GUI systems, like try Dear IM GUI,
Yeah.
try Micro UI, and just build something on those to see what
And
kinds of ideas they have, and where you like and dislike them. That will help you develop taste for
yeah.
the styles of IAM GUIs that are out there. Like I think learning from existing examples could be very helpful
Yeah, and
in a
I've
case like this because it is kind of like a big body of like judgment calls to build something like this,
it's
and
true.
seeing someone
Yeah.
else's opus for that will give you some sense of the taste that you have.
Yeah, especially DRIM GUI. And I've used both micro UI and DRIM GUI. The thing is with DRIM GUI, obviously it's become such a, you know, professional production
Yeah,
you know, library, but and also I think there's like that's totally fine. That I actually like think about it. I don't think that that's really even relevant. But like I think it has a lot of C++ isms in it that like
yeah,
don't really map very well. Like I wish I had.
sure,
I don't have function overloading.
right, right,
And
right.
so which would be nice, and you know, stuff like that. So I think like um
Yeah, and that's fair because API. So something I should say is system architecture is language independent, right? API design is about creating the linguistic interface
yeah,
onto that architecture, and their API matters. Like what you can do with a class or a function overload
yeah,
is different than what you can do with C or Zig. And I also don't even know like what the boundaries are of what is and isn't a good API trade off in Zig because API is design is coupled to the language you're using.
yeah,
So
yeah.
some of the
It
advice I
is.
give you on API design is limited on like, well, does what does Zig do to make API design possible?
Yeah. Wait, repeat that. Sorry, sorry.
As well as just like there are things I don't know about like what maybe Zig provides that could make API design for IAM GUI better in that language. I don't know.
Yeah. Yeah. It really like um it's very C-ish in terms
Mm,
of it's more C-ish
it's my
than
understanding. Yeah,
C++-ish.
yeah,
So you do have, I mean, the one thing you don't have are macros. So you know
yeah.
that
That's a little significant. Do you have the ability to do something like a defer or like
yeah,
to
you have
close the
defer.
scope?
So
Okay,
you have defer and you have duck typing. So
okay,
which is good.
yeah,
The duck typing um is a little annoying. Like it actually like actually I use duck typing a lot in the language because like it doesn't really provide anything else other than like give it a type or just, you know, or will or will imply the type, or you know, use duck typing. But you can, with the duck typing you actually have to, if you actually want to type check it, you can actually type check it compile time, and it provides you with a compile time reflection library to actually inspect, you know, the fields and inspect the types and all that stuff, which is pretty cool. But the problem is that like if you, it's called like the any type in a function parameter, and if you use that, like you kind of have to write the type check code, like um, if you want to be more type safe, which
yeah.
can be annoying sometimes.
Hmm.
Um, but yeah, I think maybe I could like I don't think in my AmGUI I really leverage like the duck typing stuff that much,
Yeah, it's
but
not immediately popping into my head why how I would do something like that. Like there's some like gimmicky examples I can think of because you can like imagine, you know, this is really it's really high level widget control stuff. It's not really worth. It's not even
yeah,
really worth
probably
getting
yeah,
into, but it's too kind of silly. But um, yeah, I think very C like so in that case either micro UI. I don't know if Ryan's UI stuff is like out as a thing you can use and play with. It'd be nice if it was
I,
because that would be one that would be good to learn from too.
yeah, I might be behind his
Yeah,
subscription,
yeah,
which
that could be.
I haven't done, but which I imagine it is, and obviously, like I mean, like there's the rad debugger. I can look at
Yeah,
it as a
use something
reference.
similar. Yeah.
Yeah. But cool. Awesome. Think
Alrighty.
I think that's all I have. This has been a great discussion. Um,
Yeah, I've enjoyed it
and
a lot.
yeah, definitely. Yeah, this will definitely be a VOD. If you're okay with that, I would also upload it to YouTube as well. This has been a
Yeah,
great
absolutely.
discussion.
Cool.
Awesome. And maybe
Alrighty.
maybe we'll do this again someday with
Yeah,
some
that would
other
be
problem.
cool.
Awesome.
Yeah, good luck with all the I'm GUI stuff, and look forward to seeing more BoksOS.
Yes. Thank you so much, and looking forward to your lab and what you come up with. All right.
Cool. I appreciate it.
All right. Have a good day, and thank you
You too.
everybody for coming out.